Okay, so what we're going to do is show how you can go among all three forms, and we're going to talk a little bit about the equation portion because the the course doesn't really go into that very well online. So we have two companies here. We actually have a third company that we'll get to later, but we have company A and company B. And so let's say that company A, they make a product called a widget. No, it's not a real thing. So don't ask what it is. It's something totally made up. It's a thing, it's a widget. And let's say the company A makes $3 for each two widgets that they sell. And we want to take this information and put it in several different forms. So, what this has given us is a coordinate. We can identify the different variables. We have the independent and the dependent. Okay, so the different variables we have are cost and widgets. Those are the two variables we have. If you are given just information like this, where you're just given a coordinate, you have to figure out what the independent and dependent variables are, which one is which. If you're given anything else, you're given a graph, a table, an equation, um, then that's already done for you. But if you're only given a coordinate, and again, this doesn't look like a coordinate form, but that's really what this is. It's a coordinate. You have to figure out which is the dependent and which is the independent variable. So that's the first thing we're going to do here. The first thing we're going to do is say, and nope, that's not how you spell it. There we go. So we have making money and the number of widgets. So money and widgets. So which one depends on the other? Um, if I'm going to ask, well, how much money are they making? That depends on how many widgets they sell. Um, I wouldn't say that the money they, or that the number of widgets they make in depends on how much money they're making. Yeah. So I wouldn't say that the number of widgets that they sell depends on how much money they're making. What is impacted is the amount they're making depends on what they sell. So that means that the amount they're making depends on what they sell. So now we have our independent and dependent variables, and independent is always x and dependent is always y. So our x variable is widgets sold, and our y is the money made. Okay, so now that we've done that, we can put this into three different forms. So first I'm going to put this into a table form. Okay, and I'm simply going to use this ratio. So for every two widgets, okay, so that's the independent. No, I'm having issues today with my x's. There we go. Okay, so for two widgets, they make $3. Well, if that doubles, they sell four, they're going to make six. And if that doubles, they're going to make, no, I don't want it to double. I could, I mean, that's not a problem, but that's just a bigger number. So let's say six. There we go. So 2, 4, 6. So 3, and 3 more and 3 more is 9. So for every 2, they're making 3. So this is 3, and this is 3 and 3, and this is 3 and 3 and 3. So I've now made a table. Well, the table has actually created more coordinates for me. So I am now going to take those coordinates and graph them. So I have 2, 3, 4, 6, 6, 9. And I can make a really lovely graph. And it's not going to, I say lovely, and if you've done any lessons with me before, you know that I don't really mean lovely. And you know how much I love my ruler, because, again, if you've been seeing any of my lessons, you know that my ability to draw a straight line without my ruler is very limited ability. But, okay, here we go. So now I'm just gonna sketch this. It's not gonna be super precise. So my x's are sold, and then I have got my profits for my y. That's kind of far away. Let me make it a little closer. Okay, so I'm just gonna have 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I have 2, which is right here, and 3. So I have my coordinate there. I have 4 and 6, which is roughly there. And then I have 6 and 9, which is roughly there. And then I can take my ruler. Oops, wrong way. And that seems about right. Yeah, that's fine. Again, not perfect. Doesn't have to be. Oops, sorry. You didn't see that, but I made another screen come up, so pretend that didn't happen. All right. Oh, that's a terrible arrow. What's wrong with me? Arrow. There we go. It's better. Still not great, but that's okay. So now I've turned it into a graph, and I can take that and turn it into an equation now, because I know where my y value is when my x value is 0, which is 0, 0. So I don't have anything to add on to the equation. And I know that my slope or rate of change is, I can either count it here, 1, 2, 3 over 1, 1, 2. And do it again, 1, 2, 3 over 1, 2. So I can say I can count it that it's 3 up and 2 to the right. Or I can do it with the slope equation from the table or the coordinates, which is my m equals y2 minus y1 over x2 minus x1. And what that really means is I'm taking, make a different color. So that means I'm going to take 2 coordinates, and I'm going to actually rotate them on their side. So like counterclockwise, so that the y's are on top and the x's are on top. I mean, x's are on the denominator. So that's what this is going to look like. So I'm going to say, all right, my 2 y variables are 3 and 6. So 3 and 6. Although, you know, when you get more comfortable with this, you'll know kind of which direction to do it. In this case, the second coordinate, that 2, is larger, and so I'm going to start with that, just so that I don't have a negative number. And then my 2 x coordinates are 4 and 2. And now I have 6 minus 3 is 3, and 4 minus 2 is 2. So either way, I get that my slope is 3/2, or 3 over 2, rise over run. So now I have my slope, and I can write my equation. So I found the slope, and all I have to do is write y equals, and then make my slope the coefficient of x. And there's nothing to add or subtract to it because my y is 0 when my x is 0, so I don't have to add anything or subtract anything onto that. Okay, so that's company A. Now I'm going to do the same thing with company B, except I have a different starting point. Now I have a starting point in an equation. So my equation is y equals 4x. And so now we're going to start in this location, or not location, but like with this information, and we're going to make the different displays. So I have an equation, and I am going to do a table. So I have the equation, and I'm going to make a table. And all I'm going to do here is use values. So I'm going to do x is 0, and 1, and 2, and maybe 3. If you use 0, you should use 3 other coordinates, but if you start with something else, 3 is fine. So anyway, when x is 0, this is 0 times 4, well, that's just 0. So when it's 1, and that's equals 4 times 0. So this is going to be 4 times 1, and that is 4. This is going to be 4 times 2, that is 8. And this is going to be 4 times 3, and that is 12. Okay, so now I have my table, which of course gives me my coordinates for a graph. So I have 0, 0, 1, 4, 2, 8, and 3, 12. So I'm gonna graph this again. I really just want to do like, that was so good. Oh my gosh. You don't understand unless you've actually seen lessons from me, like how big a deal that is, that those are not awful. All right, so we have 0, 0, which is this one. Then we have 1. Okay, we're going to go to 3. So 2, 3. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 0, 0, 1, 1, 2, 3, 4. And then 2, 8, 5, 6, 7, 8. So that's here approximately. And then this is a 3. 3, 12, 8, 9, 10, 11, 12. And it's about there. And I'm going to try my luck. Oopsie. No, can't do it 2 times in a row. Oh, that's not too bad. There we go. All right, so now I have an equation, a table, and a graph. Now, I can make a table or make a graph from the equation. Okay, so this was the direction that this went. Equation, table, and graph. But I can actually do a graph straight from my equation. That's because for a graph, I need slope and a point. So what I'm going to do is I'm going to say, look, okay, I know when x is 0, y is going to be 0. There I go. And then I need my slope. So I know here that my point is 0, 0. And I know my slope, that m value, is the coefficient of x. So here it's 4, which really equals 4 over 1, since we always have rise over 1. And whole numbers are fractions when you just put them over 1. So then we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to go here, and then I'm going to go up 1, 2, 3, 4, and over 1. I'm going to go up 1, 2, 3, 4, and over 1. So that's 8. I'm going to go up 1, 2, 3, 4, and over 1. So 12 and 3. And I get the same information. So it's, if you're comfortable doing that, which if you're not yet, you will be, but you don't have to be like right away. But it just takes out that middle step of the table. Just makes things a little bit faster, a little bit easier, so you don't have to do that middle step of the table. Okay, so now we've got company A that makes $3 for every 2 widgets. Company B also, by the way, makes widgets. Got to put that there. Widgets. And profit. This company makes $4 per widget. So $4 per widget. So currently, company B is making more, because if you figure out what they make per 2 widgets, it's that coordinate. So $8 for 2 widgets. So instead of $3 for 2 widgets, company B makes $8 for 2 widgets. So currently company B makes more money than company A. Not sure why, just because it does. Now we're going to go among those displays, or those, the displays, the forms. That's the word I'm looking for. Forms. But we're going to start with a graph. So this is a sales, I should have put this here, sales graph. And I'm going to make an equation. And I know my equation is going to be y equals mx. You have the b on there, but I'm going to look and see that this x and y, the coordinate 0, 0. So y is 0 and x is 0, which means there's no b here. There is just 0. So there's nothing to add or subtract. So I'm just going to have y equals mx. And I just need to find my slope. So I'm just going to count. I'm going up 1, 2 over 1. 1, 2 over 1. 1, 2, 1. 1, 2, 1. So my rise over run, my rise is 2, my run is 1, which is my y change. Oh, and I'm going to put, so you might have seen on the, I talked about it if you're actually in the lesson, but in one of the slides, the little triangle delta, so that represents change in y. And so rather than having to write out y2 minus y1 every time, it's really common to see it abbreviated delta y over delta x. I do that. That's a shorthand that I use, and I didn't make it up. It's like a thing. Just so when you see it, just know that's what that means. And then of course we have the run, which is our change in x, so delta x. So this equation, y equals 2x. We don't need to write the 2 over 1 because it's understood. And then I'm also going to go directly from the graph to a table. And so I have x and y. And so you'll see I already have my x's here. I have 1, 2, I actually have 1, 2, 3, and 4. And my y's, I have, when x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 6. And when x is 4, y is 8. And so that's my table. And that's my 3 forms. I went from graph to equation. I went from graph to table. I could go from graph to equation to table, but that seems like a lot of extra work, because then you're really just going from an equation to a table. rather than going from a graph to a table. So this is how you get from a graph to a table and a graph to an equation. All I did was look at the coordinates here. That's where these numbers came from. In fact, I can show this even a little bit more. Oh, no, that doesn't look good.